What did we call Cp as? Specific heat at constant pressure. But temperature has to remain constant. All things which happens in the direct process, what did we call Cv as? Specific heat at constant volume. Hello students. Now let us continue our discussion on thermodynamics, where in my previous class I have derived an expression for work done by an ideal gas, both in terms of pressure and volume. Today, let us assess some key factors, key points. Point number 1. In my previous session, we have studied about Cp and Cv. What did we call Cp as? Specific heat at constant pressure. What did we call Cv as? Specific heat at constant volume. And both these specific heats are related by an equation. Cp minus Cv is equal to R, where R is a constant which is called universal gas constant. So the constant R is called universal gas constant, and this expression is called Mayer's equation. So very importantly, the two specific heat capacities are related through Mayer's equation, and Mayer's equation is written as Cp minus Cv is equal to R. What was R? It was called universal gas constant. And the first law of thermodynamics is the consequence of the law of conservation of energy. It is an outcome of the law of conservation of energy. So Mayer's equation, which is Cp minus Cv is equal to R, relates the two specific heats, and the first law of thermodynamics is the outcome of law of conservation of energy. Now, two processes, simple definitions we study. One is called a reversible process, and the other one is called irreversible process. Now, what is reversible process? As the name itself says, the entire process can be reversed. It can be made to go in two directions. The path of the process can be changed. So we say it is a process where all changes happening in the direct process also happens in the reverse process. It is a process which can be reversed. Path of the cycle can be changed. All things which happens in the direct process can also be made to go in the reverse process. Example, slow expansion and slow compression of the gas. What about an irreversible process? The name itself says cannot be reversed. It is a single direction process. You cannot have the reverse of that phenomena. For example, burning of paper into ashes. You cannot get back paper from ashes. So burning of paper into ashes is a one-sided phenomenon. It cannot be reversed. Therefore, it is called irreversible process. Now, a very important question. What is an adiabatic process? Expression defining adiabatic process. Expression for work done by an ideal gas during adiabatic process. Dear students, in my previous class, we spoke about isothermal process. What is isothermal process? To recall, we told it is a physical process where the pressure of a system changes, volume of a system changes, but temperature has to remain constant. And we told Boyle's law defines an isothermal process. Now, we study about something called adiabatic process. Now, as we defined isothermal process, we try to define adiabatic process. So we told adiabatic process is a process where heat neither enters the system nor leaves the system. Very importantly, it is a process where I cannot add heat to the system nor take away heat from the system. Heat neither enters the system nor leaves the system, but temperature of the system changes. Such a process is what we call adiabatic process. We are barring heat to enter into the system nor go out of the system. Heat na system ಒಳಗಡೆ ಬರೋದಕ್ಕೂ ಬಿಡ್ತಿಲ್ಲ, ಆ ಸಿಸ್ಟಮ್ ಇಂದ ತೆಗಿತಾನೂ ಇಲ್ಲ, but the temperature of the system changes. That is what is called an adiabatic process. And the expression which defines an adiabatic process is PV to the power gamma should be constant. So this is the classical expression which defines an adiabatic process. What is that? PV to the power gamma is constant. And what was gamma? Cp divided by Cv. It is called the ratio of the specific heat capacities. So, adiabatic process is defined by the equation PV to the power gamma is constant. What is gamma equal to? Cp by Cv, which is called the ratio of specific heat capacities. Which was the equation defining isothermal process? PV is equal to constant. Now, the work done by a gas during an adiabatic process is given by W equals RT divided by gamma minus 1 into T1 minus T2. Again, what is R? Universal gas constant. T, absolute temperature. Gamma, Cp by Cv. So what was an adiabatic process? It is a process where heat neither enters the system nor leaves the system, but the temperature of the system can change. Work done during the adiabatic process is RT divided by gamma minus 1, T1 minus T2, and adiabatic process is defined by PV to the power gamma, which is constant. Now, here comes two assignments for you all students. We have clearly discussed the first law of thermodynamics, the consequences of the first law, and the limitations of the first law. I want you all to go through the text, assess the second law of thermodynamics, which is given by two statements. One is Kelvin's statement and the other one is Clausius' statement. Although the interpretations or the statements are different, but the conclusions of both of them is the same. So please do pick up the book, go through Kelvin's statement of second law, Clausius' statement of second law, no equations, conclusions important. If you don't analyze, try to pick it up, go through first law, you will understand it better. Now, let us try to understand the working of a refrigerator. Now, what is refrigeration? Very simple. The process of removing heat from a cold body and transferring it to a hot body in the presence of a source, external help, is called refrigeration. Beautiful. See, we always told heat flows from a hot body to a cold body. Very authoritatively I told, heat flows from a region of higher temperature to a region of lower temperature. But is the reverse possible? Can heat flow from a cold body to a hot body? Yes, but I require an external help. For example, you have the sump at home and you have the overhead tank. Usually ಏನು ಕಲ್ತಿದ್ವಿ ನಾವು? Water flows from higher potential to lower potential. But what happens here? I lift water from sump, which is the lower potential, to overhead tank, which is the higher potential, using a pump. Pump is the external source. Similarly, I can transfer heat from a cold body to a hot body using some external aid, external source, and that phenomenon is called refrigeration. And the device which performs this activity is called refrigerator. A device which will transfer heat from cold body to hot body in the presence of motor, external aid, is called refrigerator. Q2 is the amount of heat absorbed from a cold body at temperature T2. Q1, amount of heat given to a hot body at temperature T1. Then efficiency, how good a refrigerator works, how efficient is a refrigerator, is given by N. This is called eta. So efficiency is represented by the symbol eta. Eta is Q2 divided by Q1 minus Q2. See, Q2 is the amount of heat taken from the cold body. Q1 minus Q2, amount of heat converted into work. This percentage is giving you efficiency. Q2 divided by Q1 minus Q2. And we know Q2 by Q1 is T2 by T1. So eta in terms of temperatures, Q2 ಬದಲು T2 ಆಗುತ್ತೆ. Q1 minus Q2 is T1 minus T2. So this is the efficiency of a refrigerator. My next class, students, we will be working out a very important session on Carnot's heat engine, understanding its working, efficiency based on the topic of refrigerator. Until then, have a nice time. Thank you.